In this video, we're going to talk about how to use the chi-square test in SPSS statistics. As you can see from the table, the chi-square test is one of the most common and powerful tests that you can use in your research. It is a non-parametric statistical test that can be used for one sample, independent two samples, and independent k samples. As long as the samples are independent of each other, you can use the chi-square test. So let's get started. Chi-square goodness of fit test. Determine if the distribution of vaccines in the current month for eVac, dVac, fVac, and gVac is the same for the observed data of last month. The table is given. We have observed data and we have expected data. So the null hypothesis would be the current month of vaccine distribution is the same as that of last month, and the alternate hypothesis would be not the same. To answer this, let's input this in SPSS. We're not going to input the expected values, we're only going to input the observed data. So we're going to create two variables: vaccine brand, frequency. Let's assign values to them. Before we perform the chi-square test, we need to weigh cases by frequency. Now let's test this data. Go to Analyze, Non-Parametric Tests, Legacy Dialogues, chi-square. Vaccine brand is on the test variable list. And our expected values, I've already set them. For the current month, 18%, 10%, 35%, 37%. As you can see, you'll be given two tables. Now if you'll calculate the chi-square manually, you might be seeing a table similar to this. It is a contingency table. But we're focusing on SPSS, so we'll be looking at test statistics. Now the p-value of the test statistic is less than 0.0005, which is less than the alpha of 0.05. Therefore, we reject the null hypothesis. That will be the decision. Reject the null hypothesis at alpha of 0.05. Our conclusion will be that the data provided sufficient evidence that the current month of vaccine distribution is not the same as that of last month. Now let's try another example. Let's do this quickly. Example 2. They're quite similar. Determine if the vaccines are equally distributed among the 4 chosen cities of the government. Equally distributed meaning if vaccines are equal to 100%, each of the cities will have 25% of the vaccines. So the null hypothesis would be the vaccine distribution is uniform. The alternative hypothesis would be the vaccine distribution is not uniform. Let's try to do this in SPSS. We're not going to change anything here. We're just going to edit the data. So our observed frequency would be 100, 120, 110, and 100. And we'll change this variable into cities. We'll also change the values from Quezon City, San Juan City, Pasig City, Makati City. Now don't forget, before performing this test, that you weigh cases by frequency variable of frequency. Now let's test the data. This time, the expected values, since we are talking about uniform distribution, each city will have a part of the whole. If the whole is 100, 100 divided by 4 is 25. Or we can specify every value here to be 25, or we can just choose this one. All categories are equal. Let's hit OK. Same, we are provided two tables. Now let's look at this. Our test statistic, our p-value, is equal to 0.465, which is greater than 0.05. Therefore, our decision would be to do not reject the null hypothesis. We accept the null hypothesis at alpha is equal to 0.05. And our conclusion will be the data did not provide sufficient evidence that the vaccine distribution is not uniform. Now let's try another example. This time, it is the chi-square test of independence. This will have a different method using the SPSS. And one thing you'll notice, once you've done a couple of practice problems, you'll notice that the chi-square test of independence is quite similar to the Spearman's correlation coefficient. Now we'll see why. Example number 3. Determine if there is a relationship between seminar attendance and social class. 10 people were selected for each social class. Attendance was tallied. 10 people were selected, that is why each social class has a sample size of 10. Now this table may be confusing at first, but let's analyze how to input the data. Our null hypothesis would be seminar attendance and social class are independent of each other. We assume that the two variables are independent because we are testing for independence. We also assume that the alternative to that is that they are dependent of each other. They are not related, they are related. Now let's input the data in SPSS. I'm going to create two variables. I'll set the values to lower, middle, and upper. I'll create another variable, attendance tally. Make sure the social class is nominal. Now let's input the data. Actually, our attendance will be also nominal data. We're going to set the values. 1 is for those who attended, those who are present. 2 for those who are absent. And this would also be nominal. Now since each social class has 10 samples, we're going to repeat the social class 10 times. From the tally, 6 attended. 1 is for present, 2 is for absent. Let's put 6 for present. Now let us remove the weight cases first. Do not weight cases, because this is the chi-square test of independence. Now let's go to Analyze, Descriptive Statistics, cross tabs. Now let's put attendance tally in the columns, social class in the rows. Our statistics would be chi-square. Let's hit OK. We are given 3 tables. This is what you'll usually see when you're computing it manually using pen and paper. But we are going to look at this. There are many different tests in here. We're just going to look at the Pearson Chi-Square. From its name, you can already tell that it's related to the Pearson correlation coefficient, but it is not entirely the same. Now our p-value is equal to 0.142, which is greater than 0.05. Therefore, our decision is that we do not reject the null hypothesis. We accept it at alpha is equal to 0.05. We reject the alternate hypothesis. Our conclusion would be the data did not provide sufficient evidence that seminar attendance and social class are dependent of each other. Now there are many ways to do this. You can also say the data provided sufficient evidence that seminar attendance and social class are independent of each other. So that's it for this video. For more statistical analysis using SPSS, subscribe to this YouTube channel and save this playlist. Thank you.